Welcome to Creative World. In this video, we will solve chapter 3 exercise problem number 3.8. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is equal to the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 3.8. Use nodal analysis to find current I0 in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find the value of current I0 through this 1 kilo ohm resistance using nodal analysis technique. So without wasting time, let's proceed towards the solution of the network. We know that in order to do nodal analysis on any network, we have to follow some steps. First step includes finding out the maximum number of node voltage equations that can be retrieved from that network. So we will use this equation to find that figure. In this equation, n represents the number of nodes in the network. So in our case, this circuit includes 3 number of nodes. One of them is this, second one is this, and third one is reference or ground node. So enter the value of nodes inside the equation and we will get 2 number of maximum node equations that can be retrieved from this network. In next step, we have to label all unknown non-reference node voltages. In this case, this node voltage will be labeled as V1 and this node voltage will be labeled as V2. In third step, we have to assume all unknown branch currents along with their directions in the network. Current from this branch was already given in this scenario, which is I0 and it is flowing from node 2 to reference node, while other two unknown branch currents are assumed as I1 and I2 with their specific directions. Now we will apply Kirchoff's current law on these two nodes one by one to get node voltage equations. We will start from here. On this node, one current is entering 2 mA while leaving currents are I1, I2 and 4 mA. All leaving currents are taken with the negative sign. In next step, we have to replace these two currents I1 and I2 with their respective equations. Here current 2 mA is subtracted from 4 mA. The answer was minus 2 mA because larger value have minus sign along with it. Current I2 will be equal to V1 minus V2 divided by 2 kilo ohm. This resistance is connected between two non-reference nodes. So current through this resistance will be equal to the difference of these two node voltages divided by the value of resistance. Now the direction of current I2 is from V1 to V2, which is showing that V1 is higher than V2. That's why we have taken the difference of these two node voltages as V1 minus V2, while current I1 is equal to V1 divided by 1 kilo ohm resistance. Now in order to omit all denominator values, we will multiply this equation on both sides with 2 kilo ohm. Product of 2 kilo ohm and 1 kilo ohm in denominator will cancel out with each other. Only 2 will left and that 2 will be multiplied with V1. It will become 2V1. Here product of 2 kilo ohm will cancel out with 2 kilo ohm in denominator. Only V1 minus V2 will left, and here the product of 2 kilo ohm and 2 mA will result 4 volt. Now place this constant value on the other hand side of equal and open these brackets. This minus sign outside of the brackets will multiply with variables inside the brackets. The equation will become minus 2V1 minus V1 plus V2 equal to 4 volt. Now add values having same variables together. The equation will become minus 3V1 plus V2 equal to 4 volt. We cannot further solve this equation, so leave it for now and label it as equation A. It is the first node voltage equation of this network. Now we will apply Kirchoff's current law on this second node. On this node, 3 currents are entering 4 mA, 6 mA and I2, while only one current is leaving, that is I0. So KCL equation for this particular node will be 4 milliampere plus 6 milliampere plus I2 minus I0. Here entering currents are taken with positive sign and leaving current is taken with negative sign. Now we have to add these two currents together and replace these two currents with their respective equations. Current I2 as we have calculated in previous step is equal to V1 minus V2 divided by 2 kilo ohm. While current I0 is equal to V2 divided by 1 kilo ohm, voltage across this resistance divided by the value of resistance. Again, in order to omit all denominator value, we will multiply this equation on both sides with 2 kilo ohm. Product of 2 kilo ohm and 10 milliampere will result 20 volt. Here product of 2 kilo ohm will cancel out with 2 kilo ohm in denominator. Only V1 minus V2 will left. And here product of 2 kilo ohm will cancel out with 1 kilo ohm in denominator. Only 2 will left and that 2 will multiply with V2. Now place this constant value on the other hand side of equal and add values having same variables together. The equation will become V1 minus 3V2 equal to minus 20 volt. We cannot further solve this equation, so leave it for now and label it as equation B. It is the second node voltage equation of this network. Up to this point, we have retrieved two node voltage equations from this network. Now we have to solve these equations in order to find out the value of voltage V2. If we succeed to find out the value of voltage V2, we will be able to find out current through this branch that is labeled as I0 and it is the required parameter given in this scenario. So first of all, we will try to find out current V2. For that purpose, we will take equation A as it is and will multiply equation B with 3. The equation will become 3V1 minus 9V2 equal to minus 60 volt. Now add these two equations together. Minus 3V1 and plus 3V1 will cancel out with each other. Minus 2V2 plus V2 will equal to minus 8V2. On the other hand side of equal, minus 60 volt plus 4 volt will be equal to minus 56 volt. Now divide on both sides with minus 8 in order to find out the value of V2, that will become 7 volt. After calculating the value of voltage V2, we are able to find out the value of current I0 using Ohm's law. Current I0 is equal to V2 divided by 1 kilo ohm. Place the value of V2, that is 7 volt. So I0 will be equal to 7 milliampere. So the value of current I0 from this branch in this network is equal to 7 milliampere. This was exercise problem number 3.8. Thank you. See you again in next video.